Oh, hello there. I'm Bulchen, a cute bear.
Oh, hello there. I'm Nimacung, a cuter bear. Oh, ho, ho, ho. I'm sorry.
Hara.
Hey there. I'm Nimacung, a cuter bear.
Let's pull ourselves together and this time we're going to think about the number of solutions of equations.
The number of solutions of equations, for example. If it's this coming equation. Like this if we make the usual transformations. These 4 equations become like shadow clones of Ninja that don't change the solutions. We were talking about this equation. Becoming x equals 3 before. In this case, there is no other solution, so it's 1.
Yes, that's right.
So, there are also equations with lots of solutions.
Yes. For instance, look at this equation.
X is multiplying itself.
Yes, it's a bit more difficult equation than before. X is the number that, when multiplied by itself, gives 9.
And yeah.
So how much should x be?
3 times 3 equals 9, so 3.
That's right. X equals 3 is one solution.
One solution means there are others.
A hint is that a negative times a negative becomes a positive.
Oh, I see. Minus 3 times minus 3 equals 9, so minus I is also a solution.
Yes, that's correct. Today we'll skip the explanation that there are no other solutions, but to conclude, the solutions for this equation are 3 and minus 3, so there are 2 solutions.
Are there equations with 3 or more solutions?
Shall we then consider this equation next?
Well, there are lots of x. Oh, but at first glance, it seems complicated. All terms on the left-hand side are multiplied by x, so if x is 0, this equation becomes the correct equation 0 equals 0. Isn't x equals 0 a solution for this equation?
Amazing. As expected of Nimacung.
Hee. But I might not know the other solutions. There are several other solutions, right?
The discussion on how to solve this equation will come later, so for now we'll just conclude. What if x equals 1?
The left side becomes 1 minus 3 minus plus. So the equation becomes 0 equals 0. It's satisfied.
What about when x equals minus 1?
The left side becomes plus minus 1 minus 3. So again, the equation becomes.
What if x equals 3?
I'm calculating it. 81 minus 81 minus plus, so. Oh, amazing. It exactly becomes 0 equals 0 again.
That's right. In conclusion, the solutions for this equation are these 4.
So, no other values satisfy it? For example, if x equals 2. The left side becomes 16 minus 24 minus plus equals minus 6. So it doesn't become 0. So x equals 2 is not a solution.
Yes. Just like that. Values other than these 4 are not solutions. We'll skip the explanation of why we can conclude there are no other solutions this time.
Stay tuned.
Hara. Alright, let's go to the next example. We have the equation 0 times x equals 0. For which values of x this equation holds?
Alright, since anything multiplied by 0 equals 0. When x equals 1, the equation becomes 0 times 1 equals 0. so it's satisfied. When x equals 100, the equation becomes 0 times 100 equals 0, so it's satisfied. When x equals minus 3, the equation becomes 0 times minus 3 equals 0, so it's satisfied. So, it holds for any value of x.
Exactly. So, what do we conclude about the solution of the equation 0 times x equals 0?
Since every number is a solution in terms of quantity, does it mean there are infinitely many solutions?
Yes, that's right. Just to clarify, implicitly we are considering numbers in the range of real numbers. So the solution to this equation is all real numbers.
What does real numbers mean?
For instance, there is a broader range of numbers, including complex numbers like +e, which we don't use in everyday life. But if you're unfamiliar with terms like imaginary or complex numbers, you can think of real numbers as synonymous with numbers.
So the numbers I always use like 3, minus 5, 0.2, 1/3, and pi are real numbers. But there are also numbers like +e which are not real number.
Yes, exactly.
So we are only considering real numbers like 3, minus 5, 0.2, 1/3, and pi. So the solutions are all real numbers, right?
Yes, exactly.
Well done, Nimakong.
Let's look at the next example.
S.
What about this equation, x times x equals minus 1?
If x equals 1, then the left side is 1 times 1 equals 1. So it doesn't equal minus 1. And for x equals minus 1, the left side is minus 1 times minus 1 equals 1. So it doesn't equal minus 1 either. Is there any x that satisfies this equation?
No, there isn't.
To be specific, what kind of number is a solution?
There is no solution.
Don't be so harsh.
I'm serious, there isn't.
What do you mean?
Here's a hint. If x is a positive number, since positive times positive is always positive, it can't be minus 1. So that means all positive numbers are not solutions.
Right, and when x is a negative number? Since negative times negative is always positive, it can't be minus 1. And when x is 0? Since 0 times 0 is 0, it can't be minus 1 either. So whether x is positive, 0, or negative, this equation doesn't hold.
Correct. So the conclusion for this equation's solutions is
Oh, in terms of quantity, 0.
yes, exactly right. So as you see, the number of solutions to an equation can vary. There are those with no solution, meaning 0. Those with one solution. Those with multiple solutions. And those with infinitely many solutions.
Wow, I thought there was always one solution.
Hurrah.
So, for instance, for this equation with 4 solutions, isn't it okay to find just the solution x equals 0?
Well, it depends on what you mean by okay. Of course, finding one solution is not meaningless. And depending on the situation, finding just one solution might be enough. But isn't finding all solutions like understanding the equation perfectly?
I see.
Hurrah. Especially when there is no context of applying mathematics to something. Solve an equation usually means finding all solutions to the equation.
So, solving an equation is like completely understanding it.
Yes, exactly, that's the idea. Now, let's consider the cases where there are 2 or more variables.
S.
For example, an equation with two variables is like this, right?
Yes, this.
Can you find one solution to this equation?
Leave it to Nimakong.
Harald.
The sum should be 5, so... Oh, I got it. If x equals 2 and y equals 1, the equation becomes 5 equals 5, so it holds.
Right. And since this is an equation with two variables, x and y, the pair of values x equals y equals 1 forms one solution.
So x and y together play the same role as the previous single variable x.
Exactly. Good explanation.
Hee.
And just like this for equations with two variables, there are various patterns in the number of solutions.
It's complicated.
Harald. Don't mix up the number of variables and the number of solutions. Essentially, we're talking about how many pairs of x equals circle, y equals square that satisfy the equation are there.
Oh, that makes sense.
Harald. Now the first example. Can you guess the solutions to this equation?
If I can make all the terms on the left-hand side 0, it's okay. I got it. If x equals 0 and y equals 0, the equation becomes 0 equals 0, so it holds.
Good job, Nimakong. To sum it out, for this equation, there is the only solution you just found, Nimakong.
Nimakong. It's me.
Harald. Then how about this one?
Well, there are lots of x and y. How should we think about this?
Harald. Alright, here's a hint. At first glance, the left side seems complicated, but this part, and this part, and this part are all multiplied together, right?
Right, if we substitute x equals 0, y equals 0 like before, it becomes like this. So this part becomes 0 just like before. That means the left side consists of multiplications with 0, so it becomes 0. And the whole equation holds as 0 equals 0.
Is correct. If you think about it the same way, you can find two more solutions.
I see. The equation is satisfied also when this part becomes 0. So I got it. If x equals 0 and y equals 1, this part becomes precisely 0. So just like before, the entire left side becomes 0. And the equation is satisfied. As similarly, if x equals 1 and y equals 0, this part becomes precisely 0. So again, the entire left side becomes 0. And the equation is satisfied.
Yes, that's great. I'll skip the explanation, but all the solutions are found by you.
So, since a pair of the values of x and y is the solutions, there are three solutions: x equals 0, y equals 0, x equals 0, y equals 1, and x equals 1, y equals 0.
This is perfect.
Nimakong. It's me.
Let's move on to the next example.
Okay.
How about this one? There was a similar example when the equation had only the variable x.
Yes, I know this one. The left side has a multiplication by 0, so whether x equals 0 and y equals 0, or x equals 10 and y equals 10, or x equals 100 and y equals minus 100. No matter the values of x and y, the equation holds.
Alright. So how many solutions are there?
Infinite. Like x and y can take any pair of two real numbers.
That's very good. In more precise mathematical terms, the tuple xi can be any tuple of two real numbers.
Ah, so the tuple xi is like the pair of values of x and y we've been talking about.
Exactly, that's right. Well done, Nimakong.
Haha, Nimakon. It's me. This is going to be popular.
Now onto the final example.
Okay.
How about this one? There was a similar example with an equation with only the variable x.
This one though. No matter if the value of x is positive, 0, or negative, the left side always becomes non-negative. So there are no values of x that satisfy the equation, meaning there are no solutions.
That was the case, wasn't it? So what about this time?
Oh, I see. Just like before. No matter if the value of x is positive, 0, or negative. Whether the value of x is positive, 0, or negative. No matter if the value of y is positive, 0, or negative. This part will always be non-negative. So, adding two non-negative things, the left side will always be non-negative.
So what will happen to the solutions?
And, since no pair of x and y satisfies the equation, there are no solutions.
Exactly right. To summarize, even if there are two variables, there can be one solution. There can be multiple solutions. There can be infinitely many solutions. And there can be no solutions, meaning zero solutions. The same is true even if there are three or more variables.
No matter how many variables there can be various patterns. In the number of solution, that is, tuple of variable values that satisfy the equation.
Yes, you've understood it well. Hurrah.